We're on section formula. The formula is used to get the coordinate of the point that divides a line segment in a given ratio. So I'm going to state it after prove the formula that I'm going to give now and use it to solve questions. So that's it. It states that if a line with endpoints A and B with coordinate x1, y1, x2, y2 is internally divided in the ratio m:n, then the coordinate of the point that divides the line in the given ratio is this. So that's the formula for internal division. But if the line is divided externally, then the coordinate is this. So it has two formulas for internal and external. So let's prove that. So for internal division, if we have a line segment maybe with the coordinate x1, if here is the A, with coordinates x1 and y1, that's it, that's the coordinate. And if here is B, it's x2, y2, that is x2, y2. So assuming we divide AB in the ratio m:n, and this is the point, the coordinate. We want to get the coordinate of the point that divides that line in that ratio. So let's call it x and y. That's the coordinate x and y. So we'll see that we'll form two right triangles. Yes, as you can see, if you trace down, this is a right angle triangle. So the distance here is y minus y1. Y here is x minus x1. So looking at the bigger triangle, right triangle, you see that the distance from here to here is x2 minus x1. Y, the distance here is y2 minus y1. So what I'm going to do is, as you can see, we have two similar triangles. Triangle maybe AB, okay, let's call here C, and finally let's call here D. So you see that triangle AD, maybe E. Triangle ADE is similar to triangle ABC by right triangle similarity theorem. So you can easily see that triangle ADE is similar to triangle ABC. Yes, by right triangle similarity theorem. Right triangle similarity theorem. So which implies that the ratio of the corresponding side. So as you can see, M, that's the hypotenuse of this, corresponds to the hypotenuse of the big triangle, which is M plus N, is equal to this side, which is X minus X1, corresponds to this big one, which is X2 minus X1. So that's the first one. So after we compare the other one, which is as equal to this, the y part, which is y minus y1 over y2 minus y1. So I'm going to compare I'm going to compare this and this after compare this and this, so which implies that therefore I'm taking the first one, this is equal to this, and we are solving for x. So if you cross multiply, this is m times x2 minus x1 is equal to m plus n times x minus x1. So if you open up, I have mx2 minus mx1 equals mx mx minus nx1 plus nx minus mx1. So that's it. That's near far. Okay, so remember we have to get x and y because that's the coordinate x and y. So we'll make x here the subject of formulas, so which is equal to, as you can see, I have minus mx1 minus mx1, so gone. I have minus nx1, so it goes over to that side. We'll have mx2 plus nx1 equal to, I have mx and I have nx, so factor x. Therefore, solving for x, we now have mx2 plus nx1 over this m plus n. So that's for x. The same way, if we compare this and this, we now have that m times y2 minus y1 equals m plus n times y minus y1. So if you open up this, my2 minus my1 equal to my minus ny1 plus ny my1. So which is equal to, I'm seeing minus my1 and I'm seeing minus my1 here, so this is gone. So which is now, this one comes over to be my2 plus ny1, y, I have my and ny, so m plus n times y. So we now have that y is now equal to my2 plus ny1 over m plus n. So that's the coordinates of, I've proved that. So let's now solve a equation on that. Example, if you are given, so if you are given this question, find the coordinate of the point that divides the line joining this and this internally in the ratio of 3:1. So as you can see, this is x1 y1 x2 y, so this x1 y1, this x2 y2, and our m is 3 is to n, that's m is to n. So the answer is now straightforward for the x coordinate. So we have for x, so it's now m times x2. So x2 is 3, so we have 3, m is 3, x2 is 3, plus n is 1, and x1 is minus 1, over 3 plus 1, that's our coordinate, x coordinate, for y is 3 times y2, which is 4, plus 1 times y1 is minus 2 over 3 plus 1. So which is, this is 9. 9 minus 1 is 8. 8 over 4 is 2. Y this 12. 12 minus 2 is 10. 10 over 4 is 5 over 2. So the answer is option C. So that's for internal division. So that same way, for external division, it's somehow different, but the logic will still use similar logic. So assuming the ratio, so this is the point externally. You get, this is the line segment. In the previous one, the line segment is AB. So we divided internally D. But this one now, the line segment is here, which is AB. This is A and this is B. So this is our M in the ratio of this M. So this is X and this is Y. So that's the coordinate we want to get. So assuming here is, okay, let's just call here N. Here will now be M minus N. Because the line segment we are looking for, this is the line segment. Why this is just external division. So we just join this. So that's the difference between the former one and this. So we now have this point. We form right triangle. So remember this x1, y1, y this is x2, y2. So this is now x2 minus x1, y this is y2 minus y1. Y for the bigger right triangle. This is now y minus y1, y this is x minus x1. That's from here to here. So we have two triangles, right triangles, AB, maybe C, D, E. So we now see that so let's see that triangle ABC is similar to triangle ADE based on right triangle similarity theorem, which implies that the ratio of the side. So for this small one, this is M minus N over y, the big one is M. The hypotenuse of the big one is equal to, for the x, this is x2 minus x1 over y for the big one is x minus x1. So it's also equal to, for the y value, which is y2 minus y1 over y minus y1. So we'll compare this and this, and also compare this and this. So let's start with the first one. So this is M times x2 minus x1 is equal to M minus N times x minus x1. So if we open up this is mx2 minus mx1. Y this is mx minus nx minus mx1 plus nx1. So as you can see, let's look out, there is a common term, so this is out, this is out. So we have mx2, this is positive 2, move to be minus nx1 is equal to, we have x here and we have x, so we factor x. So solving for our x is now mx2 minus nx1 over m minus n. So that's the x coordinate of our external division. So let's finish off with the y value. So we also compare this and this, which is same as m times y2 minus y1 is equal to m minus n times y minus y1. So we open up, which is my2 minus my1 is equal to my minus ny minus my1 plus ny1. So solving for y, so I'll solve it direct now. This is gone, this is gone. I have y here, so if I factor it, is now m minus n, so the denominator here is m minus n. Y, this one will come over to be my2 minus ny1. No need of wasting time. So let's now solve equation on that. So this is almost similar with the other one, just the difference is the external division. So always remember that m is the one that is the greater, that's the bigger portion of the ratio. So let me shift this so that we'll have space. So let's solve. We have that for our x coordinate of the point, with that, so our x, that's our m is 3, so we have 3 times x2 is 3 minus n is 1 times x1 is minus 1 over 3 minus 1. So we are done with x coordinates. So that's same way for y is now 3. Our y2 is 4 minus 1, and our y1 is minus 2 over 3 minus 1. So which is, this is 9 plus 1, 10. 10 over 2 is 5. Y, this is 12. 12 plus 2 is 14. 14 over 2 is 7. So our answer is option A. So these are the formula for internal and external division. That's for you to get the coordinates of the point that divides a line in a given ratio. So thank you.